In this video, we will see about stack data structure. So the stack data structure is a kind of linear data structure like an array. So that array, we already know the elements can be stored and accessed in a sequential way. So by using the index of the particular element. So in the index start from 0 to n minus 1 if the array length of the array is n. The difference between the array and then stack is in array it allows the direct access of an element. So the element can be directly accessed. Any element from that element at the index 0 to n minus 1 can be directly accessed. But in the stack, we cannot directly access any element. So the element can be inserted and the element can be removed in a particular end only. So that is the difference between array and stack. Stack doesn't support the direct access of an element. The element can be inserted and the element can be removed from one end only. So the real time, I will explain one real time example for the stack. Suppose if you have a different carrier. So initially the different carrier is empty. So and then first this is the top entry of the stack. So any element can be inserted and removed from this end only. So initially the Tiffin carrier is empty. Suppose if you insert one box in this box, first we insert this box and again the next box can be inserted over this box. So in this way we can insert box one by one. So now this is the top box. In this position, we cannot be able to directly remove this box from the carrier. So if you want to remove box from the carrier means initially you need to remove the top box. So and then the top element, this is the top element. So next we can able to remove this box only. Now this is the top element in the carrier. So in this way only the elements can be arranged or organized in stack. So it can be inserted or it can be removed using one end only. That is called top of the stack. So this is the difference between array and stack. Then we will see about the operations of the stack. So in memory, how it can be represented. So the logical representation of stack. Suppose if the size of the stack is some n. For example, the size of the stack is 5. So initially the stack can be implemented in by two ways, by using an array implementation of stack. So and then a stack can be implemented using linked list. So in this example we only see about how to implement the stack using array. So as usual, to create an array we should initially we have to declare the size of the array. We should know the size of the array. Suppose the size of the array is 5. Now I am going to implement this stack using this array with size 5. So initially the stack is empty and we have to use a top pointer. The most important pointer in stack is the top pointer. So top pointer, that only by using the top pointer only we can able to know the position or index of the element which can be inserted, or index of the element which can be removed. So in the insertion, by using the top pointer only, we can able to know the address where the next element can be inserted. And in the deletion operation, by using the top pointer only, we can able to know the address where the address of the element which can be deleted or removed. So in stack, these insertion and deletion operations are called as push and pop. So push operation and pop operation. So push means inserting an element into a stack, and pop means removing an element from the stack. So now initially the top value will be -1. So -1 indicates that this current stack is empty. There is no element in the stack. So and then if you want to push a element into the stack, suppose the size of the stack is 5. So now if you want to insert a element 10 into this stack, so this stack is nothing but a array. Suppose the array is yes, you create a array with size 5. Yes, 5 means it's a simple array, name S and size is 5. So now we are going to implement stack using this array S. So for that we need to use one pointer top. Now the top equal to -1. It means the stack S don't have any element. Now I'm going to push the element 10 into the array. So into the stack, not array. So for that, first I need to make this top to 1. That means I need to increment the top value. So that means this top will be 1. Now it points to this location. So and then I need to store this 10 in this index 1. So now the top I pushed the element 10 into the stack. So again I'm going to push element 20. So in the same way, for push operation, first we need to increment the top value. So now the top value will become 2. So and then it now points to this location, and I am inserting 20 here. So next I need to push 30. The same way the top value should be incremented. It should becomes 3, and now it's point to this location. After incrementing the top value, the element 30 should be stored in that particular index top. So now I have a stack and I pushed 3 elements 10, 20, 30. So as I already told you, we cannot be able to directly access this 10 or directly access this 20 from the stack, though it is an array. Now I am using this array as a stack. I know only the pointer, top pointer. So I cannot, in a stack, I cannot able to directly access the first element or the second element. Only the last element can be accessed. So that is pop operation. So for pop operation, so if you want to pop any element, so now just return the value that is stored in the current top. So now the top value is 3. So it will return the value 30. And then in the pop we need to decrement the top pointer. So top minus minus. So actually what it will do means it will return the value that is currently stored in the top pointer. So and then it will remove that value from the stack, and then I am decrementing the top value. So now top will become 2. So now our stack contains only 2 elements. So again, if you want to perform a pop operation, then it will return the value which is stored in the top position. So it will return the value 20. So while pop operation return the value that is stored in the top position and decrement the top point. So this is the way how you can implement the push and pop operation. So and then one more important criteria we need to do while performing this push and pop operation is, suppose if the stack is already full, that is in this example we have the size of the stack is 5. Suppose if you store all the 5 elements, suppose if the stack is already full, so 5 elements are stored in the stack. Since this is a array based implementation of the stack, so we should have a size, a fixed size. So if the size of the stack is 5, that means 5 elements can be stored in the stack. Now all the 5 elements are stored. Can you able to perform a push operation? So if you perform push operation, that means top plus plus. Now the top value will become 6. And if you try to store s of top equal to 60, whether it will works? No, it will perform a runtime error. That is called index overflow error. So before performing a push operation, we should first check whether the stack is full. So how to check stack is full means we already know the size of the array. So before performing the push operation, we need to check another condition, that is full. So this is another operation apart from the push and pop. So one more important operation is full. So before performing a push operation, first we need to check whether the stack is full. If the stack is full, then we need to return a error. So stack overflow. In the same way, suppose if you insert 5 elements and then one by one element you pop the 5 elements. So after popping one element, the 50 will be removed, then 40 will be removed, and 30 will be removed, and the next pop operation 10 will 20, and finally 10. So in this case, top will become -1. So in each operation, we will pop operation, we will decrement the value. Initially, the top will be 4. So when the stack is full, initially it will be 4. After the first pop, it will become 3. Next pop, it will become 2. And third pop, it will become 1. And fourth pop, it will become 0. And fifth pop, it will become -1. So if all the elements are popped out, whether can we able to perform pop operation again? No. If we perform pop operation again, there is no element in the stack. That means it will try to return the S of -1. So the array cannot have negative index. If the negative index means the stack is empty. So before performing pop operation, we need to check whether the stack is empty or not. So that can be so we need to use another operation is empty. So these are the 4 important operations related to the stack. Pop push operation, pop operation, is full, and then is empty. So you will see the actual implementation, how these 4 operations can be implemented using C. So in this C program, so I created one array S. The size of the array S is 5. Since the size is defined as the value is 5. So and then I use one variable top. So that variable top is here used as a pointer, points to the top element in the stack. So CH is to get a choice from the user whether we need to push it pop element, or we need to check whether this so here the case 1, if the choice is 1, we are going to perform push operation. If the case is 2, we are going to perform pop operation. If the case is 3, we are going to perform is empty, and case is 4 is full. So that is choice variable. And the element is, if you perform push operation, we need to get a value to be pushed from the user. So that value, for storing that value, I am using this variable element ELE. So once you get a choice from the user, if the choice is 1, then it will get a element from the user, and it call the push operation. So here, if you look at this push operation, that push operation takes one argument. So the argument is the value that need to be pushed into the stack. And if the choice of the user is 2, then we will call pop operation, and here the pop is not taking any argument, because in the stack we cannot be able to pop element from the index, or we cannot be able to pop the element by using the value, because it don't have any direct access using the value of the element or using the index of the element. So only the top element of the stack can be popped out. So we cannot able to pass any argument, or we need not to pass any argument to the pop function. So the pop function don't have any argument. So and then if the user gives 3, that means he is going to check whether the stack is empty. So here this is empty also don't have any arguments. If the user gives 4, then it will call is full. That means it will check whether the stack is already full or not. So now First, the push operation. So push operation here, it is not going to, so as per our implementation, it is not going to return any value. So and then it's take one argument. So here the array is an integer array, so only integer value element can be stored. So the argument should also be a integer value. So as I already told you, before going to push any value into the stack, first we need to check whether the stack is full. If the stack is full, then we cannot be able to push any value into the stack. So we need to give a error message. The stack is already full. So we need to check if the stack is full. That means we need to call that is full function. If this function returns true, means the stack is full. So I will give you how this is full operation can be implemented. So if the is full operation will return true if the stack is full. It will return false if the stack is not full. So if it returns true, then we need to print stack overflow or stack is full, any warning message. So stack overflow. So we cannot add any element into the stack if it is true. Suppose if is full returns false, means the stack is not full. So we can able to push an element into the stack. So how to push means, first we need to increment the top pointer, so top plus plus, and then yes, by using that top as a index, we can store that element into the stack. So this is the implementation of push operation. First we need to check is full. If the stack is full, then we need to print error message stack is overflow. We cannot be able to do this push operation. If the stack is not full, means we need to increment the top pointer, and then we need to store that element into the top position. So this is push. And then pop operation. So in this implementation, that pop is not going to return any value. So I am just use pop void. And I already told you we cannot pass any argument to the pop operation. So while implementing this pop operation, first we need to check whether the stack has any element. That means whether the stack is empty. If the stack is empty, we cannot be able to perform pop operation. So first we need to check if is empty. That means we need to call this conditional statements, means I am checking whether this stack is empty. So this is empty. The implementation of is empty I will explain shortly. It will return true if the stack is empty. It will return false if the stack is not empty. That means the stack at least contains one element. If it is true, if it returns true, means the stack is empty. So we cannot be able to pop any element. There is no element to pop. So we need to return some error message like stack underflow. Stack underflow, we cannot be able to pop operation in this moment. Suppose is this ECMT return false. When this ECMT return false, the stack is not empty. It contains at least one element, one or more elements. So if it is false, so we need to return, or in this case just a print. We need to print the element which is stored at the top position. That means the index top. Since this is the array, it is called index. So index top. we need to return it. Once you return it, this pop operation will delete the element from the stack. So now we need to decrement the stack, top point. So this is the pop operation. Initially we need to check the ECMT constraint. It is empty. If the function returns true, then we need to print some error message like stack underflow and the pop operation. This function call will immediately end without performing any pop operation. If this ECMT is false, then it will return the element which is stored at the top index, and then it will decrement the top value. So now the is empty and is full. So since this will return any true or false statement, so the return type of this ECMT and is full should be Boolean. So it will, for example, is full. So is full, already told you, so it should return if the stack is full. It should return false if the stack is not full. So here I am using the size. The size is indicates, the variable size indicates the size of the stack. So here it is 5. So if the top points to 5, then it indicates the stack is full. So if all the 5 elements are stored, so when these all, initially the top will be -1, and when the first element is stored, the top value will be 0. When the second element is stored, the top will become 1. When the third element is stored, the top value will become 2. So when the fourth element is stored, the top value become 3. When the fifth element is stored, the top element will be the top will be 4. So after sixth element cannot be stored. So if the size is 5, the top value can be incremented up to 4. So in general, if the size is n, the top value can be incremented up to n minus 1. So if already the top value is n minus 1, then it indicates the stock is already filled. Further, we cannot be able to push any values into the stack. So the simple logic here in is full is, we need to check if top equal to size minus 1. So size indicates what is the size of the stack, maximum size of the stack. If the top value, the current top value equal to size minus 1. So in this case size is 5. If the current value of top equal to 4, it means the already the stock is filled. We cannot be able to push any values into the top. So it will return true. If the top value is not equal to size minus 1, it means it will be less than size minus 1. So it will return false. So this is the how a is full function can be implemented. And finally, there is one more important operation, that is empty. how to implement means, for example, initially the size of the stack is 5. First, initially the top value will be minus 1 and size value is 5. So I am performing a push operation, push 10. So now it will push the value, it will increment the top operation, top pointer. So it will increment. So this is the push operation. It will increment the top value. Now the top value will become 0. So top value will become 0 and then 10 will be stored in the index 0. And again I am performing another push operation 20. So now top value will become 1. So now this pointer will point to this position and 20 will be stored here. Now can I able to perform pop operation? So can I perform pop? Yes, again able to perform pop because this array contains some values. So what is the pop means? I need to print the value at the top. So this is the pop operation. So in the pop operation, if it is not empty, so in this case it is not empty, so it will print what is the top value. So top value is 20. So it will print 20. So and then it will decrement the top value. So now top value will become, so actually this value will be, it means it will be removed. So and then top value will become 0. So when top value is 0, can I able to perform pop operation? Yes, still the stack contains one element. So now also I can able to call, I can able to pop out some element from the stack. So if I call this pop again, now the top value will be decrement. So it will print the actual value that is stored in the stock 10 and this top value will become minus 1. 0 minus 1 minus 1. So actually this 10 value will be removed. So now can I able to perform pop operation? No. The stack is now becomes empty. That means there is no element in the stack. So now how can I able to know it whether the stack is empty? So this is the key here. At any time if the top pointer points to minus 1, it indicates the stack is empty. So I am going to check the same condition here. So if top equal to minus 1, so this means at this time, this means the stack is now empty. So we cannot able to perform any pop operation. So it will return true. If the top value is not minus 1, if the top value is greater than minus 1, means it will be 0, 1, 2 or up to size minus 1. In this case, it will return false. So this is the implementation of the is empty. So now in the push operation, first it will check is full. So that means it will check whether the top is equal to size minus 1. If the top value is equal to the size minus 1, then it print stack overflow. You cannot able to push any value. Otherwise, it will increment the top value and the value is stored in the top index. So in the pop, it will check is empty. So is empty means it will check whether the top value equal to -1. If top value is -1 means there is no element in the stack, so we cannot able to pop any value. So it will print stack underflow. If the stack is not empty, that means the top value is between 0 to size -1. Then it will print what is the value that is stored in the top index, and then it will decrement the top value. The same way is full, it will check whether top equal to minus size -1, then it will return true, otherwise it will return false. The is empty also, it will check whether top equal to -1, it will return true, otherwise it will return false. So this is the actual way how a stack can be implemented using array. So apart from these four basic operations, so there is one more operation in stack, that is seek. So seek, it is very similar to pop. In the pop, what we are doing means we are just deleting the top value that is stored in the top. So actually we will return what is the value that is stored in the top element, and then it will remove the value. In the seek, just it will return what is the value that is stored in the top of the stack, but it will not remove that element from the stack. That is the two different between seek and pop. That means seek only print what is the value that is stored in the top of the stack. So here, yes, so it will not do this top minus. So it will not be, this operation is not done in the seek. So as usual, like a pop, it has to check. Before this, we need to check that stack is empty. So if the stack is empty, we cannot be able to seek any value from the stack. So first we need to check whether the stack is empty. It is not empty, then we need to just return the top element of the stack, and it will not remove that element from the stack. That means this top minus will not be done. So for example, if the stack contains these three elements and top value is now 2, 0, 1, 2. So if you perform seek operation, so it will return the value 30, and it will not decrement the top value. That means top value will not become 1. Now suppose if you, after seek operation, if you perform push operation 40, then this 40 will be stored in the top value 3, because top value will in the third position. Okay, suppose, so instead of performing seek operation, suppose if you perform pop, so in this case it will return 30, as well as the 30 will be removed. That means the top value will become 1. So after that, if we perform push operation, push 40, if we perform this 40, this 40 will be stored in the position 2. So that means that 30 will be removed from the stack. That is the difference between pop and seek. So this is the implementation of stack using array. So in this video we will see about what is stack. So stack is a linear data structure in which the data can be stored in a sequential way. The difference between stack and array is, in array the data element can be directly accessed, but in the stack the data can be inserted and deleted at one end only, that is the top end. And we also discuss about the operations of the stack, how the element can be inserted by using push operation, how the element can be removed or deleted by using pop operation. So and then apart from this push and pop, there are two important operations. We need to check whether the stack is full or stack is empty. So stack is full means we cannot able to perform push. The stack is empty means we cannot able to perform pop. So and then we also discuss about how these four operations can be implemented in C. And then we also discuss about another operation, seek operation, and also we discuss about the difference between seek and pop operation. Thank you.